We're actually going to talk a little bit about drones for weed management today. In my mind, there are a couple of ways that drones can be used for weed control. One is spraying, but the other that probably is a little more common is to be used for scouting. So let's talk first about using drones for scouting. We know that drones have an advantage for scouting over some of the other types of imagery for a couple of reasons. One, because they're closer to the crops and the weeds that we're trying to scout. And two, because we can, at a relatively affordable price point, have more control over the timing of the imagery that we get. So that's one thing. Another question that we have, though, about using drones for scouting is exactly how many images do we need to capture on an acre basis, or how many images do we need to accurately quantify and identify the weeds that are present. We know there's lots of different services and softwares out there that will give us maps of weed density and even weed identification, but are those maps actually accurate enough to make a prescription spraying map for application at a later date? We've got several fields in northeast Kansas where we have collected drone imagery at sort of an typical industry standard rate of images per acre, but then we went through and flew that field and captured imagery at a higher density, a much higher density. So we have these two types of imagery, and we also have data where we went in and we ground truthed what was there. So we took early season scouting maps and identified areas of high, medium, and low weed density, and then we went in and counted the weeds that were present in that area. And so what we're finding is that by and large, the drone imagery does a good job of classifying those areas of the field correctly. However, there are some places where our counts maybe didn't give quite the same results as the imagery. And some of that has to do with the data between two images is kind of filled in, right? And that's where the image density comes into play. So we haven't crunched those numbers just yet, but we're hoping to figure out how many images do we need to find that balance between what is practical and what we need to make an accurate map that could be good enough for spraying and for even estimating herbicide use with targeted application. Targeted herbicide applications are another area where weed management practices are rapidly advancing, and there's lots of new technology. So we're trying to see with this particular project, can we make a map to better predict how much herbicide we need when we make those targeted herbicide applications. One of the benefits of using this targeted herbicide application, and some of the things that we're finding in this particular field scale study that we've been doing, is that really the value of that targeted application technology comes in how well your residual herbicides have worked. The other aspect of using drones for weed management would be to use them for spraying. One of the big limitations there is just the carrying capacity of that spray drone. And so where the technology in the industry stands right now, really we need to think about using those drones for very targeted applications. So some examples would be using them in areas where a ground rig can't travel. So aquatic weed control situations or wet situations, pasture situations. We have a lot of pasture and rangeland here in Kansas, and that terrain it's in pasture because that terrain is too rough for agricultural equipment sometimes. And so we can utilize spray drones as a weed management tool in some of those situations. Some things to consider when you're using spray drones is how the movement of the UAV itself can affect the spray deposition. When we use spray drones, we're using spray volumes that are typically much lower than what we would use with a ground rig. The research that is out there suggests that we can get adequate spray coverage with those gallons per acre, or that spray volume, as long as we're moving the drones at an appropriate place based on nozzle selection in terms of output. But we do know that because the drones are typically going to be operating a little higher than we would think of a ground rig operating, the spray pattern is going to be more susceptible to drift because of wind movement, but also drift just because of the rapid forward movement of that UAV through the field. So drones have a lot of potential, and you know, there's research over the last 5 or 6 years it's really starting to get into some of the more basic aspects of these findings, and we're excited to get to put some of this to work in the field in an applied setting.